All right, so let's try example number 5. In this example, we're asked to find the horizontal and vertical asymptote of the function. The first part is to first factor completely the function. So let's try to do that. So first, let's go ahead and take the function and factor it out. And by factor this out, it means the denominator, right? So because we have a difference of squares, right? That's a perfect square and that's a perfect square, and there's a difference. That means that we can rewrite it in this form. And the way we're gonna figure out this number is by maybe rewriting it this way, right? So that number is this number, and this number is this number, right? And then you just alternate the signs. Okay. All right, so we factor this out. The numerator does not require to be factored because it's just x squared. But that's pretty much it for that part. Let's determine the domain of the function. That means where is the function defined, and we can see here that it is defined everywhere except where the denominator is equal to 0. And we can see that that happens at x equals negative x equals minus 2 and x plus 2. So look at that denominator and set equal to 0, right? And solve for x. So this will happen by adding 2, x equals 2, subtract 2, subtract 2, x equals negative 2. So the function cannot be defined at 2 and negative 2. So because that will give us an undefined value. So those are the numbers that we're going to exclude. Right? So x cannot equal negative 2 and x cannot equal positive 2. For the vertical asymptote, we would have to try to cancel as much as we can, right? In this case, there's nothing we can cancel because there's no numerator that has the same factor as the denominator. So there's nothing we can cancel, so we're gonna use it as it is, right? So to find the vertical asymptote, we'll do the same thing. We'll do the same thing and set the denominator equal to 0, because that's all. To find the vertical asymptote, we have to find where the denominator is 0. But we already did that before, right? It's the same one as before, because the only difference that would happen here is that if there was something we were able to cancel, then we would exclude that number that we cancel. But we didn't, so they happen to be the same. Right? In other words, if you were able to cancel something, then only the one would have been the vertical asymptote, because the other one got canceled. For the wholes is, again, the factor that got canceled, but nothing got canceled. So no wholes here in this function. The X-Intercept, as we mentioned in the previous video, is going to happen whenever y equals 0. So we're going to find x when that's true. So you take the function, remember that f of x is equal to 0. So we're going to find out, we're going to set y equals to 0. So this is equal to 0. So we're going to find out what is the x value that will make this be 0. As I said before many times, the only way that a fraction can be 0 is going to be whenever the numerator is 0. There's nothing that this can be done. If this is not a 0, then this whole thing is not gonna be 0. So we look at the numerator and we set equal to 0. So we take x squared, set equal to 0. This is going to be 0 whenever actually x is 0. So the x-intercept is x equals 0. So x equals 0, y equals 0. That means the x-intercept is at 0, 0. Now, how do we determine whether this is even or odd? We look at the power. We look at the power of this 0, which happens to be 2. 2 is an even number, then that means this is even. Now, if this power would have been third, then 3 is an odd number, and so this would have been this 0 would have been an odd x-intercept. Excuse me. And let's find out the y-intercept. So y-intercept is y-intercept. That happens whenever x equals 0. We're going to find the value of y. So that happens by going back to the functions, plugging 0 for x. This will give us 0 squared, which is 0, and over negative 2 times positive 2, 0 over negative 4, which is 0. So y is 0 whenever x equals 0, which makes sense because that's the same thing we got last time. Alright, so the last part here before we graph it is to find the end behavior of the function. In other words, find the horizontal asymptote. So let's write the function. Here's our function. Okay, in this case, there was nothing we could simplify, right? So we're using the original function to find the behavior, and so we're gonna find the limit of this as x goes to infinity. And so if you guys remember, and in the beginning of the chapters of this semester, we learned that we could divide the numerator and the denominator by the leading coefficient of the denominator. So in other words, x squared. So we could divide the whole thing, both the numerator and the denominator, by x squared. So what I mean by this is this, right? So take the whole thing and divide it by x squared. So that will give us the limit of x squared over x squared over minus 4 over. So right, and the reason we can do that is because we technically multiply by 1 over 1, right? Because we're dividing by the same thing. As of course, as x goes to positive infinity, the numerator will be 1 because x squared over x squared is 1. The denominator will also be 1. X squared over x squared is 1, and this will give us that, right? So by doing this process, we have this technique where we can actually now apply the limit, right? So in this case, as x goes to infinity, right, this is going to be 4 over infinity. This whole thing is going to go to 0. And so what we end up getting is just 1 over 1 minus 0, which is 1. Yeah. And with a similar argument, we can do this for x goes to negative infinity. Now, since we already did all the math for that, we can just reapply it here. But there's not going to be no change because as when you plug in negative infinity here and you square it, you're still going to get infinity. But nonetheless, this is still going to go 4 over infinity, which is 0. So everything else stays the same. One over 1 minus 0, which is 1. And so this tells us that the horizontal asymptote is going to be y equals 1. and then we'll use all the information that we used before to graph this. So we'll begin by doing the vertical asymptotes. The vertical asymptote was -2 and +2. So we'll do a set of lines here. And then the same thing here. At x equals +2. And we also have y equals 1, horizontal asymptote. And we also have an x-intercept at x equals 0, y equals 0, which we know it's even, which means it bounces off, like a U. Now what we need to figure out is what's going on the left side of the vertical asymptote of -2. Is it going to be over here, or is it going to be down here, right? Remember that these asymptotes are going to pull the graph in that direction, and this part is going to pull the graph in this direction, right? It's going to approach it. So we need just to figure out where is it going to be, on the top or on the bottom. With the same argument, the function is going to be close to that asymptote and then close to this asymptote, or it's going to be close to this asymptote and close to this asymptote. So one of those two is going to happen. We just have to figure out which one. So all we have to do is figure out a point on the graph. If we find that the point is on top, then we know the graph is going to be over here. But if the point is on the bottom, then we know it's going to be on the bottom. So all we have to figure out is whether it's on the top or the bottom. To do that, all we have to do is plug in any point on the graph. So look at the function. It's going to be x squared over x squared minus 4, and plug in -3. That gives us 9 over 9 minus 4, which is 9 over 5, which is roughly, let's see, 1.8, right? And do the same thing for f of 3, and it's going to be the same number. (1.8). So that means at -3, you're going to have 1.8. So that's somewhere in here. At +3, you're also going to have 1.8. So we notice those numbers are above the horizontal asymptote, so we know it's going to be something like this, and then it's going to touch it, and it's going to go up. Something like this. Same argument here. It's going to be very close to this asymptote, and it's going to touch it, and then it's going to go in that direction. Right, and then we're going to write down those numbers. So it'll be -3, 9 over 5, and then +3, 9 over 5. This point is 0, 0, right? And there you go. We have graphed the function.